What's poppin'? I'm here to show you the ins and outs of how applying physics and mathematic concepts to your next game of pool and how that can better your chances of impressing everyone at the next party you go to where there's a pool table. Let's start. Despite what you're probably thinking, pool, relating it to physics, pool pays a direct homage to Newton's first law, which dictates an object at rest will stay at rest while an object in motion will stay in motion. With a plethora of concepts needing to be introduced, those revolving around specifically the physics of pool are at the core force, friction, collision, and power. Force can be thought of as an influence that changes or initiates the motion of an object. That can be described with Newton's laws. So, friction, a quintessential concept, especially revolving around pool, is what we need to understand when dealing with motion and force. It's when opposing forces that go against the initial force, such as gravity and potential ground friction, especially that of the pool board itself. And moreover, when one thing moves, it moves through or across another, otherwise known as drive friction, a type of friction that when the cue ball encounters on the table. With ball collisions, namely between the cue ball and one of the several numbered balls, or striped balls, or solid balls that you can encounter, or if you're lucky, 2 or 3, momentum, while kinetic energy is conserved before and after collisions, making every collision elastic by definition. Furthermore, the gauge of power in which the wooden rod enacts on the cue ball is another important factor to consider, as the acceleration of the cue ball can vary depending on the shot taken. The formula we've decided to utilize in order to predict and calculate the trajectory of the ball is simply put Pythagorean theorem. A concept many of us already know. These terms come into play with their mathematical counterparts, and the gameplay itself can be predicted using equations variant of Newton's laws. Wow, okay, so that was a whole lot of info. I hope you're holding up just fine, because that's just the physics component. Now to explain how Pythagorean theorem plays a crucial role. As we mentioned prior, the Pythagorean theorem can be utilized to get each number ball in the pocket. Watch as the player lines up their rod to the cue ball. The cue ball will hit the ball at a certain angle, just like the one in a right-angled 90-degree triangle. Cue ball's trajectory towards the ball needed to go into the pocket will be one of the lengths, and the length from ball to pocket will be the other, either the adjacent leg or the opposite leg of a right triangle. The hypotenuse, however, is the space from the cue ball to the pocket, which is what the player must eyeball each shot. This is also what one can measure in order to take the perfect shot. While shots range far and wide, some being 30, 60, 90-degree angled triangles or 45, 90-degree triangles, others can be as simple as a straight 180-degree line.